Hey everyone, and welcome to This Explainer. Today, we're going to dive right into how to effectively, and more importantly, cleanly handle CAPTCHAs in your Django applications. Look, if you've ever found yourself tangling with bot protection, you already know it can quickly turn a beautiful, clean code base into a total mess. Well, today, we're going to fix that.
Here is a quick look at our agenda. We're going to cover the dual nature of CAPTCHAs, run through a really practical 10-point developer checklist, map out the right architectural patterns, highlight some very common mistakes, answer your FAQs, and then wrap things up with a core design philosophy for clean architecture.
All right, section 1, verifying versus solving. Let's start by getting a clear picture of the problem, and that means distinguishing between the two primary ways your Django app actually interacts with a CAPTCHA. I actually like to think of this as the bouncer versus the diplomat. Sometimes your application is defending itself. It's acting as the bouncer, right? You're placing a CAPTCHA on your own forms to keep the bots out. But other times, it's playing the role of a diplomat. It's knocking on someone else's door during authorized automation, maybe testing, or backend data collection workflows, and you actively need to bypass a challenge.
And this comparison perfectly illustrates the technical split between those two roles. Verifying means taking a token generated by a widget, say Cloudflare Turnstile or reCAPTCHA, on your front end and rigorously validating it server-side before you process the form. Solving, on the flip side, requires a dedicated CAPTCHAAI service class that submits a task to an API and then actively pulls it for a result. Now, real quick, before we go any further, it's absolutely crucial to state that automated CAPTCHA solving must strictly be used in authorized, ethical, and legally permitted environments. This type of workflow should only be used in owned, client-authorized, or contractually permitted environments. Always respect the terms of service of the platforms you're interacting with. Moving on to Section 2, the developer checklist. If you are building this out right now, here is your 10-point checklist for a completely seamless integration. First half is configuration and setup. Number 1, explicitly decide, are you doing internal verification or external solving? 2, if it's your own form, collect that token and verify it server-side, no exceptions. 3, secure your API and secret keys in environment variables or your Django settings, guard them with your life. 4, build a reusable CaptchaAI service class so you aren't copy-pasting logic across a dozen different views. And 5, make sure your service supports the required CAPTCHA type, whether that's reCAPTCHA v2, Turnstile, or just a classic image capture. The second half is execution and safety. Here, your goal is avoiding bottlenecks. Number 6, when you submit a task and pull for the result, you absolutely need clear timeout fallbacks. Unsolvable errors happen. 7, avoid long blocking waits in web-facing views. 8, if a solve might take a few seconds, use Celery for background solving. 9, if you're using async Django views, use them carefully with AIO HTTP instead of blocking synchronous requests. And 10, sanitize those logs. Log your errors, sure, but keep sensitive data, raw tokens, and credentials entirely out of them. Okay, Section 3, choosing the right pattern. Let's see how this blueprint maps onto real-world application design, because choosing the right pattern is, frankly, critical for performance. Notice how neatly this matrix handles your design decisions based entirely on context. Use a synchronous pattern for management commands and background scripts where a slight delay just doesn't matter. You really want to use Celery when a user is actively interacting with a web-facing view so they aren't left staring at a frustrating loading spinner. And use async views, which, remember, is Django 4.1 and up, only when your entire HTTP pipeline is genuinely async safe. Section 4, common Django mistakes. Because let's be real, even with a great blueprint, things can and will go wrong. Let's review the biggest anti-patterns. These are the traps we see developers fall into constantly. Hard-coding API keys directly into your code, or doing front-end only verification, massive security flaws. Blocking a user-facing view for too long is terrible UX. Caching solves tokens for too long just means they'll expire before you use them. Retrying Celery tasks endlessly on a bad challenge will drain your resources fast. Oh, and passing the wrong site key or page URL guarantees a failure. But maybe the worst one? Running synchronous HTTP requests inside an async Django view. That will completely freeze your application's event loop, and trust me, your ops team will not be happy with you. Moving to Section 5, CAPTCHA handling FAQ. Let's hit some rapid-fire questions we consistently hear from the Django community. First question up. Should solving be synchronous or async? And when exactly should we bring Celery into the mix? Like we touched on earlier, it is totally context-dependent. If a user just clicked a button and is waiting on the other side of the screen, you cannot use synchronous solving inline. It might take 15 seconds. Offload that to Celery. Keep sync strictly for your behind-the-scenes management commands. Next question. Assuming you've already safely tucked your API keys into your environment variables, can we just cache these solved tokens in Redis or Memcached to save some time? Simply put, no, absolutely not. These systems are explicitly designed to prevent that. A reCAPTCHA token generally expires in 120 seconds, and a turnstile token in 300 seconds. If you try to cache them, they're going to be invalid by the time you actually go to use them. You have to use a just-in-time solving strategy. And finally, what exactly do we do when the solver inevitably throws an error or hits a timeout? You handle it gracefully. Before submitting, always validate your site key and page URL to prevent easy mistakes. In your Celery config, set a strict max retries limit so a bad challenge doesn't just loop forever. And most importantly, write your exception handlers to safely log the issue without dumping sensitive user data or tokens straight into your logs. And finally, Section 6, Clean Architecture. Let's wrap this up with the core architectural philosophy you should take away for your Django apps. The main takeaway I want you to leave with today is this. A reliable Django CAPTCHA setup is an intentional, well-designed application service. Please never just jam your quick submission and polling logic into a random web view. Decouple your verification, isolate your background processing, secure your settings, and handle your timeouts cleanly. If you do this, your future self and frankly her entire engineering team will thank you. So I'll leave you with this final thought. When you open up your Django codebase tomorrow morning, is your architecture ready to seamlessly outsmart the bots, or is it about to become the bottleneck itself? Thanks for joining me on this explainer. See you next time.